This is the 2016 NAPLAN paper. Calculator section question 12 says numbers such as 4, 16, 64, 81 and 100 are called square numbers, and select the statement that is always true about square numbers. Now, remembering a square number, for example, 4 is 2 squared. They're missing the square number 9 because 3 squared is 9, but 4 squared is 16. They're also missing a few other square numbers that are between 16 and 64. I'll just show you some of those. So I've just written, I've missed out the number 1, but 1 is a square number as well because 1 squared is 1. So I'll just put that one in as well. So our square numbers, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, and 10 squared is 100. Now, select the statement that is always true about square numbers. It says a square number multiplied by a square number is a square number. Now let's look at that first one. So this is bubble 1. Just some examples here. So looking at just any two square numbers, let's say 4 times 16. Well, 4 times 16 on your calculator is 64. We know that the square root of 64 is 8. That means that 8 squared is 64. So 64 is a square number. Just choosing some other square numbers. Let's say 4 there and 25. 4 times 25 is 100. We know that 100 is 10 squared, so 100 is a square number. Just some other numbers, 9 times 16 if you want. 9 times 16 is 144. Now the square root of 144 is 12. Or we can say that 144 equals 12 squared. And just another one. 9 times 25 happens to be 225. If you do the square root of 225 on your calculator, you'll get 15. That means that 15 squared is 225. That means that it appears that the first one is correct. I mean, it's correct for all the examples that we've done so far. However, sometimes in multiple choice, it might be easier to exclude others, for example. So let's have a look here. So let's look at bubble 2. A square number divided by a square number is a square number. Now, just because one of them works, I've got 16, just choosing, say, 16 and 4. 16 divided by 4 is 4. I know that 4 is a square number. That one is yes. Another example, 64 and 16. They were given up there to you as well. So 64 divided by 16 is also 4. So this one might appear that it's all yes. So what you might want to do is just choose two numbers that you know don't divide into each other and give whole numbers, or that will give an answer that's not a square number. And we can see that 81 divided by 4 is 20.25, and 20.25 is definitely not a square number. Okay. Let's look at bubble number 3. The sum of a square number and a square number is a square number. We can choose 4 and 16, add them two together, and you get 20. Well, we can see 20 is not on our list of square numbers. It's nowhere there. So 20 is not a square number. And the difference between a square number and a square number is a square number. You can choose the first two square numbers again, 16 and 4. Well, 16 take away 4 is 12, and 12 is definitely not in this list of square numbers. So that answer is no. So just being very careful, for example, with bubble 2, that, you know, especially with the square numbers that they've given you, they've missed out on 9 and 25 and 36. And these first three square numbers make the divisible statement, the statement number 2, look like it's correct, but it's not. So just be very careful. Okay, so the answer there is bubble 1. Question 13. Ethan plans to steadily increase the time he exercises each day, and his plan is shown below. He exercises 20 minutes on Monday, 30 minutes on Tuesday, 45 minutes on Wednesday, and 67.5 minutes on Thursday. And which statement is true about his plan? Well, the first one says Ethan plans to exercise 10 times longer than the previous day. 10 times longer means you would multiply it by 10. So bubble 1, for example, we would expect, so we would do 20 times 10 is 200. Well, Tuesday is not 200, it's 30 minutes. So Bubble 1 is a no. Bubble 2, 10 minutes longer, that he will exercise 10 minutes longer than the previous day. Well, let's have a look. 20 plus 10 is 30. Yes, that seems to work. Okay, so it looks like that one's okay. But then let's just keep going. Then we go 30 plus 10. Well, that's 40. And our answer is 45. So that's definitely a no. So don't look for the first one that works. Okay. The next one is 1.5 times longer. So we're multiplying by 1.5. So we've got 20 times 1.5. Well, that's 30. That's a yes. 30 times 1.5. Well, that's 45. That's another yes. 45 times 1.5, that's 67.5, and that is another yes. So it appears that the third bubble is correct. Okay, and let's just check the fourth bubble, that he is going to exercise 1.5 minutes longer than the previous day. So 20 plus 1.5 is 21.5. Well, that's definitely not 30. So our answer is, it's bubble 3, which is 1.5 times longer than the previous day. In 14, a baker uses 12.5 kilograms of flour each day, and flour costs $3.62 per kilogram. What is the cost of the flour used each day? So we'll just multiply 12.5 kilograms by $3.62, which gives us $45.25. Okay, 45.25. And it says Mason's receipt from an electronics store was torn and part of it was lost. And he knew that each 10 pack of batteries cost just under $6 and that each USB cable cost just under $11. And his credit card statement showed that he spent $72.40 at the electronics store. And the question is, how much did the flash drive cost? So if each pack of batteries was $6 and we've got 2 packs, so 6 times 2 is $12. Each USB is just under 11, so we'll just approximate and say that 11 times 4 is 44. And let's just add up and see what they add up to so far. So far that's $56. 44 plus $12 is $56. Now we know that he spent $72.40. We'll just round that down to $72. So $72 minus $56, that's approximately $16. And that would be how much the flash drive cost, $16. So $16. It says which number line shows the correct locations of 2/3, -4, 6, and -1 1/3. Now, before we go any further, -4 6 is the same as -2/3, because if you divide the numerator and the denominator by 2, you will get 2/3 or 2/3. Divide by 2, you get 4 divided by 2 is 2, and 6 divided by 2 is 3. So -4 on 6 is the same as -2/3. Now, let's see which number line correctly shows the locations of these. So here is 0, 2/3. Yes, that's more than halfway. That looks to be correct. Let's just look at 2/3 first. That one's correct. This one looks to be correct for 2/3. But this 2/3 here is really located at a half. So this bottom one is incorrect. So it's between these two. Let's look at -4 6. Now -4 6 is -2/3. Now if this is 0, this is -1 here. So this would be -1/2, or we would jump and say -1/3, -2/3, -1. -1 1/3, -1 2/3, -2. So this first one here appears to be correct because -2/3 should be closer to -1, and -1 1/3, that's jumping a third lower than -1. So this one is incorrect. This position here is closer to -2. This is more like -1 2/3. And this position here is incorrect as well. This is like -1, this is meant to be -2/3, but it's actually, if I jump back, I go -1/3, -2/3, -3/3, or -1. So this position here is actually -1/3, not -2/3. So the first one is correct. This position here, just there, is negative 1/3, this position just there. 1/3, negative 2/3, negative 1, and here we've got 0, negative 1/3, negative 2/3, negative 1. Okay, so this is incorrect, this one here, and this one is also incorrect because negative 1 1/3 is actually where I'm pointing to right there. Okay, it's where this one is. 17, it says each day a factory produces 1,250 cans of chicken soup and 1,300 cans of vegetable soup, and each can contains 400 grams of soup. So all the different types of soups, whether it be chicken soup or vegetable soup, they all weigh 400 grams. And the question is, how many kilograms of soup does the factory produce in one day? So we know that the total cans of soup is 1,250 plus 1,300, which is 2,550. Now the total mass of soup is 2,550 times 400 grams, which is 1,020,000 grams. And now we know that there are 1,000 grams in a kilogram. So the mass of soup in kilograms, we would divide the 1,020,000 grams divided by 1,000, which gives us 1,020 kilograms. The other way you could do this is actually change the 400 grams to 0.4 kilograms first up, and I think that would probably be easier. So I'm actually going to do that now. So mass of soup is it is 2,550 times, now 400 grams is actually 0.4 kilograms. And if you do it that way, you will get 1,020 kilograms straight away. You won't have to do that other conversion. So the other conversion we do here is we write that 400 grams is equal to 400 divided by, so noticing, so it's probably easier to do this, writing that 400 grams is 0.4 kilograms because your answer has to be in kilograms. So instead of multiplying the 2,550 by 400 grams, you're multiplying it by the 0.4 kilograms, which gives you your answer straight away in kilograms. So the answer is 1,020 kilograms. Okay, which is circled there. Okay, question 18. Flynn asked each of his classmates, what is your favourite sport? And we can see the results in this table. And 10 people said that they like tennis. Their favourite sport was tennis. 13 people for netball and 9 for soccer. And the question is, what is the probability that a randomly selected classmate's favourite sport is netball? And round your answer to the nearest hundredth. Now we can see that total classmates is 10 plus 13 plus 9, which is 32. And the probability of that someone's favourite sport is netball would be 13 divided by 32. Now, when 13 over 32 is 13 divided by 32, which is 0.40625. Not sure if there's any decimal places after that. However, we want it rounded to the nearest hundredth. So remember, we've got our tens place there that I'm highlighting and my hundredths place there that I'm highlighting. So it's to the second decimal place. And this 0 gets rounded up to a 1 because the 6 follows the 0. So it's 0.41 to the nearest hundredth. Okay, there it is there. And now the next question. Now it says Sophia wants to buy the type of pasta that is the best value and which type of pasta costs the least per gram. So we need the cost over divided by the grams because we want the least costs the least per gram. So we want the cost per gram. So we put the dollar amount divided by the grams. So we can see the pasta shells, which is bubble 1, are $2 for 150 grams or per. I can write per or for if you want. So $2 for 150 grams. So if we do 2 divided by 150, I mean, you're going to get a very small answer. So it's easier to change the $2 into 200 cents. So it's 200 cents for 150 grams. So we can divide those two quantities. So it's 200 cents per. Actually, I'll keep this as per. 200 cents per 150 grams. So we divide the 200 by the 150 and we end up with 1.33. So that is 1.33 cents per gram. Now we can do the same for this second bubble. It's $2 for 250 grams. Now, this is one way we can do it. We can do it other ways and work out the cost, for example, for 100 grams if we wanted, or for 50 grams might be easier. You can work out the cost for 50 grams, but here I'm working out the cost per gram. So if it's $2 for 250 grams, that's the same as 200 cents for 250 grams. So it's 200 cents divided by 250 grams. So you divide them and you get 80 cents per gram. And then we continue with bubble 3 and 4. We've got $3 per 400 grams, or 300 cents per 400 grams. 300 divided by 400 is 0.75 cents per gram. And the last one ends up being $5 for 500 grams, which is 500 cents for 500 grams. You divide your 500 by 500 and you get 1 cent per gram. Now, that is one way to do it, okay? We tend to do it that way in year 8, actually. So the cheapest one there will be the 75 cents per gram, which is that one. There is another way that we can do this. The other way to do this is to work out the cost per 50 grams. Now, 50 grams, we know that 50 goes into each of these numbers. So we see how many 50s go into 150. So 150 divided by 50 is 3. So if we divide $2 by 3, we'll get the cost for 50 grams. So $2 divided by 3 is 0.666 recurring, which is 0.67. Now, 250, sorry, this is not right. 250 divided by 50 is 5. And so $2 divided by 5 is 40. So it's 40 cents per 50 grams for the second lot of pasta spirals. Now the spaghetti, 400 divided by 50 is 8, so we divide the $3 by 8 and we get 0.375. So it's 37.5 cents per 50 grams. And the fettuccine, 500 divided by 50 is 10, so we divide the $5 by 10 to get the cost for 50 grams. And it's 50 cents for 50 grams, and as we can see again, that this one here, sorry about that, is the cheapest, the third option. Okay, so you can do it either way.